All right, so let's throw number 67 together out of 10.2. And nobody cares that you love yams. This is a brick. We're cooking a brick.
Are we making
It literally says you cooked a brick. It says a hot brick is removed from a kiln at 200 centigrade above room temperature.
Which is ridiculous.
Maybe they fired a brick.
Okay, so here's my picture.
Wouldn't it burst
Now,
or
they're
melt at that point?
Here's a kiln, right?
Fucking
And
hot.
from out the kiln, I get a brick.
Celsius.
This brick is hot, which is why it's radiating heat. It's 200 degrees centigrade above room temp.
200.
Cool?
That's not.
Then what? Over time, the brick cools off. Yes, I have seen things when you take them out of the oven, and they do, in fact, usually cool off. After 2 hours have elapsed, okay? So after 2 hours, my brick is now only vaguely warm.
What? Really?
Yeah, that's what it says. It says,
Well, I know it says that. It just doesn't. 200 degrees Celsius above room temperature in only 2 hours. It's vaguely warm.
yeah,
Because why not?
Yeah.
that's actually fairly slow.
That's, yeah. All right, keep going. Sorry.
Okay, anyway, it went from 200 degrees above room temperature to 20 degrees above room temperature, which I'm advertising as vaguely warm, but is probably still hot enough to burn you. Okay, let T be the time in hours since the brick was removed from the kiln. Okay, T. Time in hours since T is 0. T is 0 is this part of the picture. Cool. Let Y is H of T be the difference between the brick's temperature and room temperature. Assume H of T is an exponential function. Okay. So they also told me H of T is heat in brick. How much hotter the brick is than the room. Cool? How hot, which is why we use H. Right? And then they also told me to assume that this thing is an exponential function. What the hell does that mean?
It means
It's e to the t.
some kind of exponent.
Yeah,
Oh.
this means this thing looks like H of T is, I don't know, some like A e to the KT or something. You guys with me on that? No?
That seemed out of nowhere.
Yeah, this thing seems like it's really out of nowhere. What is that?
It's natural.
Super upset now.
Oops. So I wrote this. I wrote H is A e to the KT.
E is the exponential part of it, and
Yeah.
T is a part of it.
Why does this thing look familiar? Has anybody seen a model that looks a little bit like this?
Yeah, but
What if I change the letters? No?
You mean
No.
R?
Doesn't-
No.
This doesn't remind you of Algebra 2?
Oh.
It's the investment stuff.
Oh yeah, this is the population model from Algebra 2.
Yeah.
Or the continuously compounding interest formula from accounting class. Or the way bricks lose heat from differential equations class. Or Newton's law of cooling from Physics 1. No?
Was that in physics one?
I don't know.
I think it was.
It's been like forever since
I
took
took physics already and I don't remember that.
Okay, so clearly this was not going to come to any of you guys. Is that accurate?
Yeah.
Okay, so scrap it. Let's think of something else to put in there instead. So if they tell me it's an exponential function, what does that mean?
Getting closer to zero.
That's good. It's getting closer and closer to zero. So I think the temperature function is probably going to look like this, right? You guys see that? Like H probably looks a lot like this. That's a t-axis. This is a degrees centigrade axis.
Would it not be zero, but the room temperature?
Oh yeah, H is how much hotter is the brick than the room, right?
Yeah.
So that's going to taper to zero. If I talked about this in terms of temperature of the brick, right?
It would never touch.
It's going to taper off to the temperature of the room.
Yeah.
And it's never actually going to get there, but at some point, like out here, it's too small for me to tell the difference. You guys see that? Okay, so functions like this look like that. You could trust me on this, or we could just make something else up. So another thing that looks like this is just some kind of freaking number, right,
Over X.
to a power t. You guys see that? That's what an exponential function is. It's a number to the variable power. And then you need some kind of a... So why do I need one more thing here? What do I know about when t is 0 on that?
T0 equals 200.
Yeah, t of 0 should give me 200 out, right? But when I plug t as 0 into number to a 0 power, what do I get out? 1, regardless, right? So I think maybe I ought to have at the very least a 200 in here. You guys see that? Okay, so I think my best guess right now is h of t is 200, some number I don't know, to the t power. For simplicity's sake, I'm going to call this thing frickin' k or something. Okay? And that's why I'm calling it k. I expect you to smile on that. Really, call it whatever the hell you want. Doesn't matter. So, I need to find out what k is. How do I find out what k is? What do I know? No. What do I know about this thing? I know that at the beginning, right, when I plug in 0, I better get 200 out. That's this.
Oh, if you plug in 2, you should get 20.
And when I plug in 2, I better get 20 out. You guys all see that? So h of 2 should be 20.
No. And then,
Okay, so-
But h of 2 is something else. It's 200 k squared. You guys see that? So what's k?
So you use
Square root
so
of 10.
Divided by 200.
Or square root of 1 over.
How about divide by, screw it, I'm not doing that anymore. Multiply by 1 over 200, right?
right.
So that'll get you what?
20 right
1 over 10 is k squared. Right, 20 over 200 is 1 over 10. And then what?
Square.
Square up both sides?
Doesn't that introduce the plus minus problem?
It does. So we should plus or minus square up both sides. And so we should get plus or minus 1 over the square root of 10 is k. And then how do I pick which one to use?
Wait,
Obviously, plus.
Did I lose you?
no, but can't wouldn't you multiply by square root of 10 as a to get rid of the square root on the bottom? 'Cause you're-
Oh, I don't care if you rationalize the bottoms.
Okay.
That's a skill we know about.
Okay.
Sorry. I know you learned to do that.
No, you're good.
Yeah, that skill is good for comparing things.
It's been a while
In the
since I've
ages
dealt with it.
before we had calculators. I don't care if you guys do that, so don't worry about it. So I got k is plus or minus 1 over the square root of 10. How do I know whether I should put plus the square root of 10 or minus the square root of 10 in there?
It's decreasing, shouldn't it be?
I don't know. How can I check?
Plug in both.
Good. I can think about plugging both of them in, right? So if I go back here, right? Let me go over here. So I'm going to take K. I'm going to plug it in. So I'm going to say, all right, H of T, right, is 200. And then in here, there's a 1 over the square root of 10, maybe with a plus or minus, right? And a T there. Okay, so what's another thought? Like, what's going to happen if I plug in a number that's like 1? Why would I pick 1?
When the temperature is at 1 degree above.
The thing to the one powers itself.
Good. I'm going to plug 1 in because it's easy to do in terms of powers, right? I'm also going to plug 1 in because it should be an intuitive point.
It's half.
You guys see that? It's halfway between 200 degrees and 20 degrees somehow, right? Is it actually going to give me halfway between?
No.
Probably not, because it's going to cool off faster at the beginning and then slow as it gets more towards room temperature, right? But is it going to be somewhere in the middle? It damn well better be. So if I plug 1 in here, and I had minus 1 over the square root of 10, what are you going to get out of this thing? Don't think too hard.
Negative number.
Yeah, it's going to be negative, right? You guys all see that? If I plug 1 in here, I'm going to get a negative out of that. Is this brick going to have gone below room temperature halfway in between these?
Yes, sir.
No, not a chance. So I know the plus one's the right one to pick. Boom. Done. There's H. Is that what I was supposed to do? I started doing this and didn't read the directions.
What's the first part?
Part A, find a formula. Good. How many degrees, part B, so this is A. Part B, how many degrees does the brick's temperature drop during the first quarter hour?
So 30.
Use that and then plug in.
Okay, so hang on, I'm ditching the way I got that. Oh, I should remember that H is how much hotter than the room is the,
Here.
okay? So I'm supposed to find out H of when? Quarter hour is 15 minutes, right?
Yeah.
So what am I plugging in right here?
15.
15 over 6.
What? What are you plugging in right here? What units does this thing take? What are the inputs?
Okay, so
How do I know they're hours?
Is it total?
Because you freaking made it that way, ma'am.
Yeah.
When you use T as 2 to calibrate this model,
Oh,
you force it to be in hours. You did that.
So,
So, how about a quarter? So H of a quarter is 200, 1 over the square root of 10 to the 1/4 power. Yeah, that's a 4th root. So this is going to be, what? I'm like done with hand calculations right there. If you want an approximation, cram this in a calculator. None of you are reaching for a calculator.
Oh, I thought you were done. I voted
Do it right. Be careful. Make sure you close the parenthesis on your square root. Thank you.
Are you kidding me? Oh.
Good.
No, I did it wrong.
They're wrong. Okay, cool.
I got it. I'm just messing with it.
Yeah, you want the little caret, this thing, and then parenthesis, 1/4.
Well, like, you could square root of
No, there's not a convenient 4th power button. There might be.
There's only,
No, I don't see one.
there's only a cube root, and you have to go into the
You
menu.
got this thing. and then you
Do
got
this.
X power.
Oh.
Yeah, you can pick what power.
Oh, and I screwed this up when I was writing it
Way
down.
more work than to do prints.
So 149
978.
cool, 150.
Yeah. you're next.
So, what's the answer to their question? They asked, how many degrees does the brick's temperature drop during the first quarter hour? And I said, h of a quarter is 150.
So it drops about 50 degrees.
Good, 50 degree drop. 50 degrees centigrade drop.
Nice.
That's a horrible sentence. I'm calling that a sentence. It's not really. I'm not clear what the subject or verb is. Okay. During the next quarter hour.
After this?
Yeah, so after this,
So, yeah, after a half hour in total.
okay, so after a half hour, so you need h of 1/2,
Can you just
right? Because h doesn't do time since the last calculation, right? It does time since the beginning. So if I want the next quarter hour, that's going to be between a quarter hour and a half hour. So I'm going to need to do some funky business here. So, sorry, hand calculation wise, this is 200, 1 over the square root of 10, raised to the what? 1/2. So you need to square root 10. Oops. What'd you guys get? Cool. Roughly 112.5 degrees. So what's your drop? Good. Make sure you're not taking the drop from the beginning, right? Because you're doing the next quarter hour.
It's 37.5.
So it's like 37.5 degrees. Oops, I'm not doing that. 37.5 degrees centigrade drop. You guys see why it's crucial that it drop less?
Yeah, because it's slowing down.
Right? Because if it dropped 50 degrees every quarter hour, right? It wouldn't take long for this thing to reach absolute zero, and that would be a little bit bizarre. Okay, so how about this one? Find sorry,
No, go ahead.
you got something?
I was saying it'd be like you're cooling it, like on purpose, if it was dropping more.
Yeah, if it dropped below room temperature, I'd be like, wait a second.
Yeah.
Somebody's taking energy from my system. It's probably Trevor with his goddamn perpetual motion machine.
I'm not thinking that.
All right, part C. Find and interpret H inverse of Y.
Do it. Just do it.
Okay, so how do you find an inverse function?
You reverse engineer one T, we can do a bubble diagram.
Okay, we only have one instance of T, so we could bubble diagram. Or we could do the other way. I'm going to do the other way because Lauren was asking about stuff vaguely like this in my office earlier.
Thanks.
What?
Thanks.
It was good.
No, I know. Thanks for.
Oh, okay.
Third time's a charm.
Okay, so what do I do first to solve this for T?
I'm trying to get T by itself.
I gotta get T by itself, right? T is stuck in the exponent of that stuff. So-
divide by 200 first.
First things first, I gotta get this out of there. So I'm gonna move that to the other side. So I'm gonna multiply by 1 over 200 on both sides.
Yes, sir.
So I'm gonna get y over 200 is 1 over the square root of 10t. And then what are you gonna do?
Log.
What log what log do you want to do, and what log should you do?
Oh, you want to do natural log.
No.
You want
Okay,
to
you
log
should do
because the
natural
10's
log.
there.
You should do natural log. What log do you want to do?
Normal
That's
one?
the only one.
That's the only one. How about, I want the t off of this shit, right? So why don't I just apply the inverse function for 1 over the square root of t, square root of 10. So I think I'd maybe log base that,
I don't know how to do this.
right? Which is really what I would get in a bubble diagram. That would be nasty. So log it instead with a natural log.
That's what we're thinking here. No one's thinking the other thing. Well, you're
Yes.
weird.
Indeed, I am, sir.
Okay, so I got this, right? Equals, and this is the step I want to make sure you're doing right. What do you get?
T.
Oh, wait, isn't
times t.
Is it T?
Okay, so you get log of this crap. Right? You just log both sides. Now, why was it a good idea to log both sides?
I don't know.
keep it equal?
I don't know.
To get the t.
Why not?
Of the log.
Good, because you can use a log rule to drag this t out of there, right? So
Is it?
log rules will get you to this step. So we're going to do a log rule to both sides. So we're going to get, or sorry, we're just going to do a log rule to that side. We're going to have log of y over 200 equals t natural log of 1 over the square root of 10. And then we wanted the t by itself, right?
Divide by natural log.
Yeah, so I should divide the natural loggy business out of there. So I'm going to divide both sides by natural log of 1 over the square root of 10. There's actually some log rules you could do to make this a little better. You might think about that. I'm not going to because I'm lazy. So you're going to get t is natural log of y over 200
Minus.
divided by natural log of 1 over the square root of 10.
Can't you just use other log rules to? make
Yeah,
that
you
look
could
better?
fiddle this around, but I'm not going to.
I hate log divided by
Cool.
log.
Do you guys want to see more log rules there?
Yes.
Yeah, I hate logs.
Because I don't remember most of the log.
Okay, so
Log was never discussed before in my life.
what?
This is new to me.
Really?
Really?
Oh, okay. So that's the un-e function.
It's the only reason I remember since chemistry.
Yeah, wasn't that?
Since that's the most current thing. I have them all written down.
Yeah.
I remember.
Okay, so right now I'm rocking this, and I want to use log rules to simplify because you guys are whiny.
Thank you.
So
I finally kept it.
first things first, you remember log rules.
Yeah. How about you just
Yeah.
Okay, so let's write them down.
Yes, please.
Now I'm fully erasing the problem that started this. Okay, so the log rules you need are the log of a times b. So log of the quantity a times b is log of a plus log of b. Log of x over y is log of x minus log of y. And log of x to the y is, oh no, log of square to triangle is triangle log square. In other words, you can make products inside, addition outside, you make division inside, subtraction outside, and you can make powers inside, some kind of funky ass multiplication on the outside. Usually I'll refer to this one as, we'll use a log rule to drag the power down. You guys see that? Because really what I'm doing is I'm taking this exponent and pulling it out and putting it down front. Cool?
I use A's and B's in
Yeah, sure. This is the one I'm going to use the most. So here, what do you got?
Log y minus log 200.
Okay, so on the top I got log of y minus log of 200. And on the bottom, don't use the one you're thinking about using. Use the other one.
I'm not.
So 1 over the square root of 10 is 10 to the minus 1/2 power, right?
Yeah.
And you can do all this.
So drag the minus 1/2 out front, so you get minus 1/2 log of 10. Cool.
That's not that. I can see that.
I don't think this is particularly tons better, but whatever. Okay,
I got that a lot easier.
so that's T. Cool. Why was I doing this?
Because it works.
No, why did I start doing this problem? What did they ask me for?
Find the inverse. of
Yeah, I was
y.
supposed to find H inverse of y, right? Okay, so that's what this thing is. This is H inverse of y is this crap. Natural log of y minus log of 200 over horrible business. See why I wanted to leave it the other way, but you were all wrong. Okay, anyway, what do I do with this? They wanted me to find and interpret. What have I so far done?
Found it.
Found. How do I interpret?
Plug something.
Yeah, what does this thing do?
Explain what it does.
So what did H do?
It takes
H,
time and gives you a temperature.
Yeah, H took times and turns it into temp above room, right?
So would it take temperature above room temperature and give you a time?
Yeah. This thing tells you when does the brick reach a certain temperature above room temperature. You guys see that? So this thing is, when does the brick reach Y degrees centigrade above room temperature?
So would the range be restricted because you can't go past 200?
Oh, that's interesting. How about this? The domain
Okay.
of this thing, right, should be restricted to values between
0 and 2 hours?
0 and, that's the range.
Remember you inversed,
Oh,
so
yeah.
you flipped.
Yeah, so this thing should be, I should be saying what degrees can I put in here,
Oh.
right? What temperatures above the room can it be? I think it can be any place from 0 to 200 degrees, right? This one being allowed,
0 not.
and 0 not being allowed, right? Because it can be 200 degrees above room temperature. I know that happened at time 0. And it cannot be 0 degrees above room temperature because,
0 is impossible.
yeah, because it won't ever actually reach that value. It's just tapering off.
Wait, wouldn't 0 be room temperature now?
Yeah, 0 would be the brick reached room temperature. I know it can't, so that's not allowed. Yeah, there's a horizontal asymptote there. And then, okay, part D, which we just did E. So E is that it tapers off to this horizontal asymptote and that it never actually gets to room temperature. It's always a little bit warmer.
I understand that.
Just some
Just go ahead and ask why.
But
But no, I wasn't going to ask why. I was just saying it's irritating because like, it would eventually reach room temperature.
it eventually exceeds my ability to tell the difference between room temperature and its temperature, right? But in math land, yeah, it never quite gets there. All right, how much time elapses before the brick's temperature is 5 degrees above room temperature? How do I do that one?
Plug it in.
You plug 5 into the inverse.
Yeah,
If you
So-
have a temperature and want a time.
I would say the answer to part D is quite simply D. H inverse of 5.
Really? It said find it.
Hours. Right? Could you get a number out of that?
Yeah.
if you want to.
Yes.
Yeah, sure. Plug it in there, right? If you want an approximation, go for it. Otherwise, I'm willing to leave it as h inverse of 5 because I'm tired of this problem. Anything else? You guys cool? Any of the rest of this? Further questions on this brick thing? Okay, cool. Good talk.